All right, so welcome back, Precalcers. We are continuing on from the problems that we were working on yesterday. This is what I asked you to attempt last night. Now, just number 3 was all that I requested. Looking at it, this one I hope is locked in. Like we have it, no issues whatsoever. If not, now would be the time to talk and ask questions. If you do not understand how we get this, this is the shot. Yeah, absolutely. All right, Sean, if I said imagine a 130-degree angle in your head, you might be able to do it. On here, you can definitely do it. I'm going to start here at 0. You tell me when to stop. About there? Okay, and this is my 130 right there, yeah? So, with this, when we're talking bearings, always from north or south. Always. Am I closer to north or closer to south? So, I know that I start north and I turn that direction. And let's just do a little thing here. That's 90 degrees. How much more do we have to go? 40 degrees would be this angle. So there's where we say start at north, turn 40 degrees to the west. Okay. Now, looking at this one. When I think about this, this is how I break it down. We have degrees, minutes, and seconds. It's strange.
I find it so weird that it doesn't go by hundredths or thousands. It goes by the
60th or 3600ths. I also agree with you wholeheartedly. I think it's super strange. But as we're looking at it, we didn't refer to hours yesterday. We used degrees. But do you guys, like, if this was thought of as hours, minutes are out of 60th, and seconds are 3600ths of an hour. Are you okay with that? So if we break it down with that kind of similar idea to how we think about time, do you agree that 13 degrees can be thought of as 13 degrees plus 2 minutes is 2/60ths of an hour, and then 38 seconds is 38 3600ths of an hour? Like, this is a weird thing to, like, it feels strange when we do it.
What is the reason behind this? Like, I don't understand.
I wish I could tell you the motivation for why these were developed and stuck with.
It's an engineering thing.
It's an engineering thing. Remind me when we have a little bit of downtime. I'll Google it, because I legitimately don't know why we would use this, especially with modern tech.
I feel like hundredths and thousands would actually make sense, but the whole minute thing, second thing, like.
So welcome to customary units.
Yeah.
Like, I don't know that this is done elsewhere in the world off the top of my head, but I'm not an engineer in the U.S., nor am I an engineer in Europe. So, like, I'll check into that. But it's weird. I get it. But 2 minutes is a 60th, 2/60ths of an hour. Like, this part we're cool with, I think. Do me a favor, if you weren't able to get this one, will somebody tell me what 1/30th is as a decimal? Or 2/60ths? Probably with a calculator. 1 out of 30. Out loud, K-Dog. 2/60ths, yes. Or 1/30th, same thing. .0077.
I got 1/3.
You did 20/60th then?
Or 2, yeah. 2 divided by 60.
Yep. That's 1/30th. I agree.
You added the 13.
Okay. Plus, this one's even going to go further, but somebody hook it up. 38 3600ths. Get real loud because I don't have a calculator in front of me.
0661.
Are you sure?
Oh wait.
I don't agree with you.
Don't believe
I
me.
don't.
There's an extra 0 somewhere. Go ahead, Barsega, what'd you get? 38 out of 3600?
It's
01. It is 100th. 1001, sorry. 05. Could we add all 3 of these together? Do that for me real quick. Double check, like they're ugly, and I know whether how hard we go on this. Did I submit this?
Wait, do we round up or down?
I would round up, yeah. Is that 2/60ths? That's not 2/60ths, is it? 0.03 is what I had for this. Somebody second that? 0.033. Okay, Kalisha, check your thing. I don't know where this number came from. I didn't recognize it. 0.033 sounds more believable. I bet you did a 600th or a 6,000th is my guess. Okay, when we add these up, let's check. We get 13 point what? 044. Cool. Sounds reasonable. Looking at this last one, it's the same situation that we did yesterday. We have this example from our notes. If you weren't able to do it yesterday, I want you to check it here. Try this one with your neighbors. I'm going to give us a second while I get some other stuff entered and set up. But talk it out. If you're on an island by yourself, feel free to follow bearings and move yourself off the island. Cool. Before we convert to bearing, and we will get to bearings here in a second, but I'm already thinking I'm in quadrant what? Negative 43 degrees is in quadrant 4. I'm thinking it's south, and then there's some amount, right? Now, before we change it to full bearings, I think we can all agree it's still 43 degrees. Plus 0.72 of the time left, right? So if we use this example that we had, wait a second. I didn't mean to use the exact same example. That's my bad. But let's check it. 0.72 of an hour. Because that's my 72%. How much of it do we have? 43, and there's some ugly decimals in there, right? So the fact that we get 43 left in there, I bet the 43 comes from my 0.7. I would argue that. Like, I think it's going to happen. So here we go. We have negative 43 degrees still, plus, you said 43? 43.2 minutes. So I'm going to call that 43 minutes. And then we need 0.2 minutes left, right? So there's two values that we should see wind up being the same. We have our 0.2 times the seconds, which is our 60. And I know that this is going to be a fifth, and that's what, 12? Okay. Alternatively, do me a favor real quick and check 0.02 of 3600. That's not going to be the right number. Scratch that. I don't need it.
It's just plus 70.72 times 60. Is it not 72 over 100 times 60?
So it is. 72 over 100 is 0.72. That's the only difference that I've made.
Right.
Yep. So that covers our 0.7, and then we have 0.02 left, right? Or 0.2 left with it.
Yeah, for some reason
Cool.
I thought you put 0.72 over 100.
No, you're good. And that's, I should have done it the same way that we did it yesterday. I did not mean to use the same numbers. But we get negative 43 degrees, 43 minutes, and it winds up being 12 seconds again. Is that true? Okay. At this point, this angle is very specific. And realistically, Huggins just kind of a thought here. If I had 43.800052 degrees, like there's a lot of decimals to carry in through there. That situation I can see where this might be a more reasonable way to talk about it. If we have a ton of rounding, this is a shorter, easier way to refer to it, but it's so unnatural.
72 over 100.
Yeah, instead of saying 43.70000002, maybe it'd be easier to say 43 degrees, 1 minute, and 12 seconds.
Oh,
Like,
yeah.
I can see the utility in it. We don't do a ton of it. Cool. This angle, if I were to sketch it right now, we started here and went negative 43 degrees, 43 minutes, and 12 seconds. Is that a true bearing, though? No, but we can think this up. I know that this is my negative 43. Here's where my bearing lives. Where did we start?
Can I add? You go.
So Sean says south. I agree. Go ahead.
I just wanted to ask where the 0.2 comes from if you already used the 0.72.
So it's the 0.02 of the 3600 is what's really happening. Don't stress about it. We're just glossing over this right now.
But when I do it though,
Yep.
I would only do 0.72 times 60.
Okay, and you'll get 43 point something, right?
Oh.
What do you
okay.
get? 43
And
point.
then you're taking the decimal off. Of
Yep,
it.
I'm taking the
Right,
0.2 that's left over.
Sometimes it just
No, you're good. It's wonky. Okay, so let's count up then. I need these two angles to add up to what? 90. So let's think here. Do you guys ever use, some of you worked at a store or have counted money, I imagine. Have you counted back money? Did you guys ever learn to count back money? Like if somebody has a bill that's $8.13 and they give you a 20, could you count it back to them to make sure, like to show them that that's the right change? Do you know how to actually do it rather than just saying, here's your $12 change?
Yeah.
Okay, like counting up from the price?
Yeah.
You think we can do the similar thing here? You go 48 seconds, and now you're at 43 degrees and 44 minutes. Everybody okay with that? 48 more seconds. So then we need to go, what is it, 16 more minutes?
Yeah.
So I add 48 seconds to get to 44 minutes. I had 16 more minutes to get to 44 degrees. And then I need, what is it, 46 more? Did I lose you guys in that?
Yeah.
Okay. Let's talk this out. It's so weird to be with the time, and I don't want to spend. We're spending more on this than we probably should, but that's okay. Let's start counting up. I want to get to 90. From 12 seconds. To get up to the next minute, we have to add what? We have to get up to 60.
48.
So I get to 48. That's how much I need left. Now I'm at 44 minutes. Do you guys agree with that?
Yeah.
Okay, from 44 minutes to get up to the next full hour, I need, why 40? Whoa, where are you getting these numbers from? I'm at 44 minutes and I need to get to 60. 16 is the minutes. So if I'm at this angle and I go 16 minutes and 48 seconds further, I'm now at 44 degrees. Does that feel okay?
Yeah.
Okay, from 44 degrees, let's get to 90. I think it's 46.
So what are we finding right now? The other angle?
We are finding the actual bearing as we look at this. So this was our true angle and standard position.
Uh-huh.
Now we said we're going to start north or south.
We're gonna start. Oh, you have to start at north or south.
Yep,
You
for
can't-
bearings.
You can't start at east or west.
Not for true bearings.
Okay.
We started south, we turned east. This one, I just want to be super clear. 100% guarantee I'm going to ask you to do this. We're going to use this on a problem here in just a moment. The second one, I will not give you on a quiz or a test, but anybody who winds up going into engineering, you will see this again. The third one, same thing. It will not show up on a quiz or test, but if you go into engineering, you will talk about these further.
I know I'm asking a lot of questions about this, but
That's okay.
why did you do the 0.2 times 60 there, but on the other one it's to get back down from 38 you do divided by 3.
To get back down
Like-
from
like-
38. Yep,
C38 and
Yep.
you put it over 3600.
correct.
So if that's the second, then
So convert back. If you took 43 60ths, I bet you're going to wind up with 0.7.
0.7.
Yep.
Right, yeah.
And then if you took, let's see, 12 3600ths, I think you're going to wind up with 0.02. And you're going to add them up and we'll just walk the other way.
Right, but why is it times 60 and not 3600?
Because we started at minutes, we're breaking it down, we're saying what's left over, let's convert the rest of it to the seconds.
I don't know, like maybe
It's-
that sounds stupid right now.
You do not. It's a weird concept. I might sound that way right now, just because I don't think I quite understand your question. Let me kick this around. We'll come back. I'll talk with you specifically. Okay. This one is the one that I care the most about. Everybody good with that one?
Yeah.
All right. Let's do a boat problem. And I'm just going to copy and paste it. We just did 1 through 3. We have a little tiny bit more to look at for new stuff. However, I want you guys to read through and start working number 4 on that worksheet. For these, you have to draw a picture. Just full disclosure. Here is number 4. I'll give you a minute. I want you guys to draw your picture. Get ready for this, make sense of what's going on, and we will come back together in 3, 2, 1. Looking at this, saw some great work, some great triangles, but I want to make sure that we're here. So I'm just going to check this out. We have a boat that leaves a pier going a particular direction. On my page, is it going to go left or right when it leaves the pier? It's going to go to the left because that's west. Okay, 15 minutes later, I instantly change. That's so we can deal with the nice stuff. I change course to, instead of going straight left, I'm going up and to the left now. Okay, not very far up and to the left, like mostly up. And I go at 10 knots. I do this for 12 minutes. The end question is, where are we? And if we want to go back from the pier, what bearing and distance have we left or have we arrived at? So check it out. You're never going to see me draw fancy pictures, but I can draw a heck of a pier. There it is. It's fantastic. Now, as we do this, it is entirely up to you whether or not you include these. I find them helpful, but you might not. I'm going to put an axis here. This one's going to feel silly when we do it, but I'm going to start leaving. I go which direction first? I go to the left. So here I am going to the left. Straight west, right? Due west. So here we are. I've gone some distance. I didn't measure it yet, but we can reason it out. For this, we are going at 8 nautical miles per hour, or 8 knots. We've gone for how much of an hour? 15/60ths, right? So there's back to it. So that's 1/4 of an hour. If I go 8 miles per hour for 1/4 of an hour, I've only gone 2 miles. If I go 8 knots for 1/4 of an hour, I go 2 knots. 2 nautical miles is really what it's going to be. At 8 nautical miles per hour for 1/4 of an hour, I go 2 nautical miles, which I'm just going to call that KT. 15 minutes is how much of an hour? No, we got it. Take 15 and multiply it by 4 and tell me what you get. It's the same weird thing because you're wanting to think decimals.
You're thinking about
4 and 20. Okay, yeah, I got it.
Yep, okay. So I then get here and I do what? I turn, so check it out. Here's my bearings just to kind of keep me straight a little bit again. I start going north, and then I turn what direction? 16 degrees to the west. And I'm going a little bit faster for a little less time. I have no idea about the scale. It may not be right. Cool. Here it is. If you go at 10 nautical miles per hour for 12 minutes, or 1/5 of an hour, how far have you traveled? 2 knots again. Cool. There it is. I'm asked at the end to find this one. I want the length and the bearing here. Here's the bearing that we're after. Realistically, does that exist on our triangle? No. So I bet we can find this angle in there is what's probably going to happen, and then we'll have to adjust it. So I'm stuck, but I'm open to suggestions. Oh, I could use a right triangle first. What do you mean by that? No, you're probably onto something. It's just hard. Are you struggling to describe the triangle? Where would you like me to tell me where to stop my cursor? Here? And do what? Okay, I could go straight up. It intersects a weird part of that, though. Would you agree? Like, I love the idea. I'm going to do a little bit different. I think we would run into problems there. What if, however, I went to right here and dropped straight down? Now I get 3 right triangles on the board. I have the small right triangle here. I know there's that other, I guess, not right triangle at this point. I have 2 right triangles on the board. I lied to your faces. Okay. Well, let's see if we don't have some angles and stuff here. I know that distance is 2. What was this bearing that I went the second time? So what's this angle? I don't know that I agree with either of those numbers. I like 74. How?
There's a rain.
What? What did you say?
Like the rain.
The bearing. I just couldn't click the word that you said. My brain wouldn't put together. 48 degrees. What? 84. That's backward. There we go.
What?
84 degrees. Because this is 16 right here, right?
74.
Oh my goodness gracious.
We should maybe try we do geometry again.
We're going to do some trig, but we're going to shake these out first. I stopped swearing at home, and goodness gracious is something that comes up a lot when I'm trying to avoid it. And oh my gosh, those are the 2 things. Zeke has now started saying, oh my gracious, and I love it. All right, here we go. This is 74 degrees because 74 plus 16 gets me up to 90. Now, we are going to label a few pieces. For this, if I could find this distance, I think we'd be golden. Right here is the distance that I need. So all I'm going to do is I'm going to shade this one roughly, And I'm going to blow that up over here just so we can look at that triangle. This is that same triangle just blown way up. We know that this vertical is 2. This angle was 74. And we're looking for this. Opposite and adjacent, tangent will do the trick. So if we're looking for this, you could find the hypotenuse instead, if you'd rather. You could try. The 2 is the hypotenuse. Adding my picture here. Where's the 2 represent? I should have drawn my picture big the first time. Rafa, you saved us just now.
The side from
It's the green, but when I drew this, my mind mixed it up because of the way we drew it. The 2 is the length of this one. Everybody cool with that? So I'm going to put the 2 right here where it should go appropriately, and Rafa, huge shout out again. I'm now trying to find x. And the reason I'm trying to find it is because if I know this length, well, now are we all goofed up? Nope, we're going to be okay. Okay, find me x first.
Also, can we just back it up to how we did knots and minutes and how we changed that to
I'm going to use NM for nautical miles, okay?
just like a car?
Like if you go 8 miles an hour for 15 minutes, how
Oh,
far
the
did you
ratio,
go?
okay.
Yeah.
I was just brain was moving for a second. I didn't want to have it in a formula, you know?
That's it, Sean. It's up there. What is x? One more time? 0.55. Can I get a second? All right. With that x in mind, here's where I'm thinking. Right triangles are the best triangles. Whether or not that's true, I don't know, but they work really nicely for our trig. If, just maybe if, we had a triangle where I knew that this bottom side was 2.55, and we had this, I'm just going to make up a number right now. I don't know what it's going to be. I bet it's like 1.7-ish. I don't know. Could we find this side? If I had those 2 sides. On this big triangle that I'm looking at, which is really just this big triangle right here, we know a couple things about it already. So, we found that this distance was 0.55. There is more than one approach to doing this. I'm okay with whichever one we go with. Could we find this length now? I want you to find me that length. There's 2 ways that you could take it. I'll show them both. I'm going to mute my screen. I'm going to hide it from you guys for a second. I want you to find me this side.
What's the 0.55?
That is what we got when we solved for this x. And I suppose I should show that. We had opposite and hypotenuse. So we had the sine of 74 degrees must have been equal to opposite is y over hypotenuse is 2. That'll get me there.
I love it.
But I'm going to check, because I don't know that I believe your numbers. Is it 0.922? Did somebody do cosine? Whoever got 0.55, and I don't remember, like it happens, my guess is you used cosine. For x. Oh my gosh, I'm all right. I can think of very few times where I've been flustered and just flustered out of control in front of everybody. It happens. What's up? Did you just make a joke, Sean? All right. We haven't done anything fundamentally wrong other than I keep speaking in the most possibly confusing way. That's my bad. Hopefully this video isn't near as confusing, right? Okay, we're going to double check. I have a calculator in front of me to make sure that the numbers that I get and the suggestions that I give are correct. We're going to back up for just a skosh. If I want to find this x, I have this angle, opposite or adjacent right here. And this is the hypotenuse. So I don't know what on earth I was saying or why I was saying it, but I think I can conclude the following. The cosine of 74 degrees is equal to what over what? X over 2. Now, I'm going to multiply both sides by 2, and I'm going to type it into my calculator, verifying that I'm in degrees. So here we go. Mode degree, feeling good. 2 cos of 74. I agree with the 0.55 again. I don't know why I didn't before. I'm going to go to 4 decimal points so that if I don't just keep typing in my calculator, I have it. Are we all up to speed at this point? Goodness gracious. I feel terrible for it, but we're fixing our errors. Now, I made the comment that we get this other side right here, which I'm going to do this because I'm going to keep seeing it. Boom. As we start looking at this bigger picture, I need that vertical side because I'm looking to make a big right triangle. We have a couple options. If, based on the board, you can certainly easily call this y, and you could get it using the sine. Do you guys agree with that? So check it out. The sine of 74 degrees is equal to what over what? Y over 2. When I solve this, I then get y is equal to what number? And I hear 1 point, say it again. 1.9225. 1.9225. Now, this picture got more convoluted as I went, but I'm going to draw a simple picture at the end. Here's the main triangle that we're actually looking at. We had this length was 2.5513 because it's my 2 knots that I went initially plus this part of it. Are we all cool there? I then went up how far?
1.9.
Okay, I'm asked to find this angle up here, my bearing. It's not on my triangle. However, this one is. Could you find this theta right here? Tangent would do the trick. Could you find this distance right here? How? You can Pythagorean theorem it, or you could use trig and just rearrange it as long as you solve for the hypotenuse. Pythagorean theorem or trig works. I want you guys to do 2 things for me. Find me this angle theta and find me the distance. Cool. I'll give you a moment. I'm going to double check and calculate it myself. If you're watching this on the road, please pause it, work this out, and resume in 3, 2, 1. We get 37 degrees right here. Pythagorean theorem or trig? How would you guys solve for this? Okay, you use Pythagorean theorem. Give me a value. I'm going to use trig.
3.1945.
Okay, I hear 3.9 something. I'll hit it in a second. If I use sine, I think that I would have opposite is 1.9225. 9225 over the hypotenuse, right? Which means I could multiply by the hypotenuse and then divide by sine 37. I'm just going to confirm your number. If I take that 1.9225 number, 1.9225, and I divide it by the sine of 37 degrees. Say yours again.
3.1945.
3.1945 is exactly what I get as well. Whether you use Pythagorean theorem or trig, we get the same answer. I think trig's faster. Either one works. Do we have all the information that we need to answer this question at this point? I think so. What were we actually asked to find? Distance and bearing. Now, because I've drawn this larger triangle once we put it together, I'm just going to add this last little piece back on. If this is 37 degrees, we never start from west. I always start bearings from where? If this is 37 right here, what is this angle? 43 or 53? 53 degrees. Okay, and I started at north and I fell which way? To the west. So I'm out of room. I'm going to write it right here. The boat is how many knots or nautical miles away?
3.19.
Cool. I'm never going to include that in the end answer, but I'm fine with that. 3.2 nautical miles. I'm just going to call it miles away at a bearing.
Wait.
Yes, miss. The 3.1945, I just rounded. What's the bearing? Start at north.
North 53 degrees east.
Okay, we're going to fix the language, but I agree with west. We're still going to fix the language. 53 degrees west of north. Like if you say north 53 west, I'll know what you mean, but people are going to look at you
Write
silly.
it like that, but say 53 degrees
West of north. Yep.
Yeah.
I will not count you wrong if you say it backward. If you write it backward, I will. Okay. Goodness gracious. Or oh my gracious. We are going to look at a short video real quick. We have example 5 for simple harmonic motion. Now, that sounds so scary. When you hear harmonic, what do you think of? You think of sound? You probably should think of sound. Sound travels in waves, right? Any other things that you've seen in a math class that travels with waves? Or is represented by a wave? Like literally all the trig stuff, right? So it would make sense then that if we're looking at something like sound, that it would travel with waves and we could model them with trig. Do you guys agree with that? So this last little piece, we're going to look at number 5, and then we'll see the data or the video that I recorded to make sense of stuff, and we'll just look and talk about the different parts of it. So here we go. Last little piece, and I better get a book because I don't want to mislead anything anywhere. I want you to read through number 5 first. I'll copy and paste. We have an equation for simple harmonic motion, and that probably doesn't mean a ton to you, but that equation, I hope, is a lot more manageable than the word of harmonic motion. This equation, if I hadn't said it's simple harmonic motion, I said here's an equation. We know what this looks like, I think. At least kind of. What is the general shape of this graph?
Wave.
It's a wave, right? It's a cosine wave, so it starts up and then it falls. Now, beyond this, what's changed about it?
Its amplitude is 6.
Its amplitude is 6 at this point. Now, beyond that, anything else changed?
Something about the period, but the period's whatever that is.
The period is 2 pi divided by, what's the coefficient?
3 pi.
Almost. A little bit more.
No. I think that the argument is 3 pi, not 2 pi. Oh, my bad.
You're close. Put your two answers together. I heard 3 pi and 3/4. I think the number connected to my variable t is 3 pi fourths. It's a little bit of both yours. It's just bx, right? Just like we do in our graphs. Now, when we're talking harmonic motion, lots of things travel in harmonic motion. Here's my example. I recorded this earlier, and we can look at this if you'd like. I have this, and it's at 44. That's my starting point. I'm going to drop this weight that's connected to a spring, and it's going to drop down, and then it's going to do what? It's going to come back up, and then it's going to come back down, and it's going to come back up. If we looked at this, here's my motion, and we'll just watch it in slow motion. I started at 44, 43.
43.
Okay, I'm back to 43, and I'm just going down and back. Now, I see it happening. I'm losing a little bit of energy here. If we looked at this and had location or position and time on the same graph, we would see that it starts at its highest point, and you don't have to draw this yet, but it starts, and then if this is position in meters and this is time, it starts to fall until it gets to its lowest point, and then a little bit more time, it starts to come back up, and it just does this, right? This is harmonic motion. We see that rising and falling, that cyclic nature that happens with so many things in our world. This is called harmonic motion.
But is it
Back and forth at regular intervals.
Is it like decreasing intervals? Getting wider.
So in real practice, yes. In a nice high school math and physics concept,
Yeah,
it's
all this-
no energy is really
every
lost.
period is the
Yep,
same.
yep. But in reality, you're absolutely right, because obviously that spring's going to lose energy. Cool. So let's look at this problem again and realize that, hey, that's what they're talking about here. Now, with this graph, it runs, cosine normally has an amplitude of 1, and it goes up 1 and then down 1, so the range is 2, right? That's the total amount of distance that you could cover. This graph goes up how many? 6, and then it goes down to where it started, and then it goes down 6 more, right? So what's the full distance that it could possibly travel? The biggest displacement? 12. It's twice the amplitude. We have it. The maximum displacement, it's got to be 12. We know what the graph looks like. We can apply it here. All right. There's our first part. Just like in the one that we had, I know that my wave goes down 6 more, and then back up. There's 12, and they didn't give us a unit, so I'm just going to say units. Don't know what they are. Twice the amplitude. Okay, these next couple little pieces, we are overlapping so hardcore right now. What did we talk about at the end of physics this morning? Oh my gosh, frequency F. Okay, looking at this. They are certainly the same idea, how fast something moves. It's periodic cycle that we're looking at. But I want to make sure that we get the math approach to this. I'm going to hook it up. If you want this in your notes, and I guess we already had this earlier, you guys remember what frequency was defined as first hour? So omega divided by 2 pi. Okay. In this particular problem, I've taken my regular period that's 2 pi units, and I've condensed it by what constant? 3 pi fourths. The amount of angle that we're going through in this is that angle 3 pi fourths that we have. Now, we're working within 1 unit at a time. I can see that it would just be 3 pi fourths is where it'd be at. This is 3 pi fourths, 4 hour omega. This will always be given if I give you one of these. I'm still dividing by 2 pi. And I'm just plugging into a formula at this point. It's omega, or the angle that we travel, over the regular period of your function. Okay, could you solve that and simplify it? Do it for me.
So the omega is the argument?
Omega is the angle, the coefficient in our argument, yeah. Yep. And it turns out that I don't love when they switch to notation, but this all has stuff that we've already seen.
Yeah.
What do you guys get when you simplify this? 3/8? I'm good with that. So the frequency here is 3/8. Now, for this, what does that even mean? Like, if we think about the units, are there any units right here on my radians? Do radians have units? No. But this is radians per second is how it's always given. All we have here is per second. Now, if we look at this, 3/8 is a nice number. I know it doesn't seem like it's 0.375. 0.375 cycles per second is what we're seeing from this data. So 3/8 of a full period, 0.375 cycles per second. That's what we're really finding with our frequency. Okay. The distance from the origin at time 6. Remember, if I have a function, if I plug in a value, an x value, or a t value in this case, it spits out a y value as well, right? With harmonic motion, I'm literally just going up and down. Could you guys find me the value of this d of t, but instead do d of 6? Now, if that question you're looking at, you're going, what? D of 6 is literally just anywhere that there's a t, what am I going to replace it with? 6. So this becomes 3 pi times 6 over 4. I want you guys to find this value. I had 5.8182. Can somebody second that? Cool. 5.818, so I'm going to say 82. And we're talking about distance. We'll just call it units. I don't know what the distance is. All right. This last one is going to be the piece that's kind of like a glance ahead at stuff. The least positive value for which d of t is equal to 0. Now, we have not talked about this at all, but I think, correct me if I'm wrong, you guys have solved an equation before. Check it out. I have not talked like hardcore or at all about the trig part of this, but do we know how to undo a cosine function? Our cosine would undo it, right? Now, if I'm asked you to find the least positive value t for which this is true, it's equal to 0, I'm going to ask you right now before, I'm going to say solve this for what? Solve this for t. Play the algebra game. It's not a calculator problem right off the bat. I want you to give me an explicit answer for t equals something awful, and then give me your approximation. Solve this for t is our statement or our problem. I'm going to pause it here. We're going to continue on. So let's check. I'm going to walk through it. Are you looking, if I label these and call this 1, 2, 1, from 3 to 4? Yeah, let's check it out. First step, 1, I want to isolate anything with t in it, which means I don't want this 6 here right now. I'll just divide both sides. Boom, we're done. I now have this expression. This is just this carried out. Once I'm here, I realize I recognize, weird, the t is inside the argument, so we need to undo it. I'll take the arc cosine of both sides. Here's what I get. I do this in one step. What undoes a multiply by 3 pi fourths? You just multiply by the reciprocal, right? Multiply by 4, and then you could divide by 3 pi. I just do it in one operation. This is a number. In fact, I think it's going to be a nice number. I think it's just 4 over 3 pi. I'm pretty confident that it's 4 over 3 pi, because cosine, arc cosine of 0 should be 1. This is exactly equal to 4 over 3 pi, or approximately equal to some amount of time. Somebody have it, because I do not. Say it again? Show me what you typed in. Don't erase it. So remember, if you're dividing by 3 pi, it divides by 3, and then it multiplies by pi. Parentheses around it. So you're still dividing by 3 and then multiplying by pi. Whatever you want to be divided by, make sure it's everything gets divided by it. Like, that's an easy fix. Easy mistake to make. Like, don't stress that one as long as you're mindful of it. Say your number again. 0.46? 42. Second? Okay, so we got a second. Sean disagrees. Four divided by 3 pi. I get 0.4244. Cool. All right. These problems, they're just application of our trig. One of the things that I'm going to show you in the text, but I don't think we need to jot it down because it's just a matter of like actually getting our notation correctly. When we graph sine and cosine, we looked at sine and cosine in this form. D plus or minus a sine of bx minus c. This is how we've seen it, right? That's a standard that we do. That's the way that we graphed it. Did we have the same thing everywhere here in this problem? I think so. Now, more specifically, I just want to show you. We did. Here is another variation of this. This is our definition. We have the exact same thing going on. Notice the period is 2 pi over b when we normally do this. What did they call b here when we go some amount of angle? They just called it omega. That's over one time. This is how much angle we went through. Frequency, if I asked, is there a way if you have period, could you find the frequency of that wave? What did they do? They flip it. If 2 pi over b is your period, your frequency is b over 2 pi every time. Now, that winds up being b in this situation, in this context. We think of it as omega, but it's the same value. It's just a number in front of it. Cool. This stuff relates back and forth with pre-calc and physics so well. I cannot stress enough physics that we do. Like, it's valuable, and we're learning a lot about physics, I hope. I'm learning a ton about the planets right now in our other class. But all this math gets easier the second we use calculus. More meaningful, maybe. Okay, so the cool thing is this disaster of a lesson is over. So that's step 1. Step 2, we just finished the chapter. Oh, I was going to turn and point at it like that. We just finished the chapter. Now, unless anybody's just dying to have a test on Monday, here's what I'm thinking. I want to start a practice test on Monday. It's not going to be a team test because we have some people that aren't here. I will post it on Monday for everybody. But this weekend, you do need a little bit of practice with some applicational stuff. So we'll go here and here and here. And look at that. We're just blasting through. The homework over the weekend. I think it is going to be practice. I thought they were back on Monday. We'll call it an actual practice test. So it's graded like a big homework rather than a quiz. Your homework over the weekend is these problems. 1 through 5 is vocab. Sorry, homework 4.8, page 337. And you get problems 1 through 5, 15, 16, 24, 30, 41, 53, and 60 through 62. One problem that we did not look at explicitly, but if your ears are open, it's going to hook it up. You guys saw it in geometry, I know it, but it's been a while. If I said solve a triangle, do you know what I'm asking you to do? All the angles and all the sides. Find everything about that triangle is what it means to solve. Number 5, you are asked to solve the triangle. So I'm going to get a pre-calc book that doesn't have all the answers in it. Charles, can you through your book for a moment? That'd be all right with you? I meant to record this hour. I even opened this up and put my phone up there to practice, and then I forgot to do it. All right, so for those of you on the road, 1 through 5, 15, 16, 24. Cool. Here are points 1 through 5. Questions 1 through 5. Okay, after 5, can somebody tell me the number? 15 and 16. Finding an altitude. 24 and 30. So here's 24. It's a lovely lighthouse problem. Number 30 is a wonderful angle of depression with a geosynchronous satellite problem. 41 to 53 I think is true or false, or even or odd. Nope, that'll get there. 41 is a lovely survey problem. 53 is a lovely harmonic motion problem. And 60 through 62 are short answer followed by true or false. Cool. You guys have fun. Raiders, good luck when you play. Just want to stress the importance of those of you that have been emailing me stuff. I appreciate it. If you return you don't have anything, I'm putting zeros in, and you might kill your eligibility. Later.